Hello and welcome to Logarithms and Exponents Practice Part 1 by the GEM Tutoring Center. In this video, we'll go through 3 practice problems that have exponents in them, and we'll solve for the variables that are needed to be solved for. So in this first problem, we have 3 to the x plus 3 to the negative x equals 2. So the first thing we can do for this problem is rewrite it. It's going to be 3 to the x plus 3 to the x to the negative 1 equals 2. So we can write it like this because 3 to the x to the negative 1 is going to be 3 to the negative x because the x and the negative 1 get multiplied. So this is the same as what we have above. Then we're going to let y equal 3 to the x. And we're going to substitute this into the expression. So we're going to get y plus y to the negative 1 equals 2. And that's the same thing as y plus 1 over y equals 2. Okay, because y inverse, or y to the negative 1, is just 1 over y. And then we're going to put this y up on top of the numerator of the fraction beside it. So that's going to be y squared plus 1 over y is equal to 2. Then we're going to move this y to the right, so we'll get y squared plus 1 equals 2y. Okay? And we're going to move this 2y to the left, so we'll get y squared minus 2y plus 1 equals 0. All right. Turns out this is a pretty easy function to factor, so we'll just get y minus 1 times y minus 1 equals 0. So y is equal to 1. And remember what y was. Y was 3 to the x. So 3 to the x equals 1. Now there's two ways we can go about doing this. We can say, well, 3 to the 0 is equal to 1. So x must be equal to 0. That's true. There is a little bit longer way to do it using logarithms, where you take logarithm of 3 to the x. I'm using ln here, but you could use log too, as long as you do the same thing on both sides. So ln 3 to the x equals ln of 1. This x comes down. It becomes x ln of 3, and ln of 1 is 0, just like log of 1 is 0. So it must be true that x is equal to 0. So whichever way you do it, whichever path you choose here, you will get x equals 0. Okay? And if we notice that 3 to the 0 equals 1 from the beginning, remember that the original expression was 3 to the x plus 3 to the negative x equals 2. If we notice this right here from the beginning, we could have just said, well, 1 plus 1 equals 2, so x must be equal to 0. But for the purposes of solving this problem, we went through the general process that you would go through using y equals 3 to the x. If this was not 2 and this was something like 5, we would not be able to just say, oh yeah, 3 to the 0 plus 3 to the 0 equals 2. We can't do that because that's not equal to 5. So then we would have to go through this general process of letting y equal this exponential value and then making it into a quadratic equation. And we wouldn't get something as nice as this. We would get a quadratic formula requiring quadratic equation. We'd have to use a quadratic formula, and it would get kind of messy. So to keep this example simple, we selected a nice number like 2 in this equation, and we went down through it and we found that it was easily factorable, and we were able to find what x was. Okay, but if you didn't have 2 there, if you had 5 here, or 7, or any number that's other than 2, you would not be able to use x equals 0 right away. You would have to solve for x. Okay, let's go to the next problem. So here we have 64 to the x plus 1 over 256 to the x, and that's equal to 64 squared, and we need to solve for x. So something that's going to make this problem much easier to solve for us is that we notice that all of the numbers have a base of 4. They're all 4 to the power of something. So 64 is actually 4 to the 3, and 256 is 64 times 4, which is equal to 4 to the 4th. Okay? So these are two important facts that we're going to use as we simplify this problem and solve it ultimately. So the first thing we can do is notice that 64 is 4 cubed, like we did up here, and that's getting multiplied by x to the x plus 1, or sorry, it's getting raised to the power of x plus 1, and 256 on the bottom is 4 to the 4th to the x, like this. And 64, we already said, is 4 cubed. That's getting squared. Okay? So we have this kind of a setup. Now what we're going to do is separate out this x and the 1. And we're going to get 4 cubed to the x times 4 cubed to the 1. Remember that since these are the same base, 4 cubed and 4 cubed, I know that 4 is the base here, but the base of this x exponent is 4 cubed, this whole thing. And the base of this 1 exponent is 4 cubed, this whole thing. So when I take the base 4 cubed to the x, and when I take the base 4 cubed and raise it to the x power and multiply by 4 cubed to the 1, the x and the 1 will add and we'll get 4 cubed x plus 1 as we had up here. Okay? The bottom is still 4 to the 4 to the x, and the right side is still 4 cubed squared. Okay, now here comes another interesting part. We're going to actually flip this 3 and this x. We're going to move the x inside, and we're going to take the 3 outside. Okay, so what that's going to look like is 4 to the x cubed times 4 cubed to the 1, which is the same as before, but we switched out the x and the 3. We're going to do the same thing on the bottom with the 4 and the x. So it's going to be 4 to the x to the 4th. Okay, and we can do this because 4 to the 4th to the x is 4 to the 4x. And if you do 4 to the x to the 4, it's still 4 to the 4x. So it doesn't matter which order these are in. We just take one out and leave the other in. We just take one number, one of the variable or the number out. In this case, we took the number out and we're leaving the variable inside of the parentheses. Okay? So, we say equal to, this is still 4 cubed squared. Now what we're going to do is move this 4 cubed to the 1 down here. So we're going to get 4 to the x cubed over 4 to the x to the 4 is equal to 4 cubed squared over 4 cubed to the 1. Okay, what we're going to do now is simplify. We recognize that 4 to the x is the same base on the top and bottom here, but this is to the 3rd power, this is to the 4th power. So if we cancel out the common part, which is 4 to the x cubed, we're going to be left with 4 to the x to the 1 on the bottom, because the 3 of them got canceled out with the numerator. Now there's just 1 left on the bottom. That's equal to, and this is, on this side, there's some cancellation too. We have 4 cubed squared over 4 cubed to the 1. Since they're the same base and 2 is bigger than 1, we're going to have 4 cubed to the 1 on the top and 1 on the bottom. Okay? So this is the same thing as 1 divided by 4 to the x, and that's equal to 4 cubed. Okay, I'm just getting rid of the 1's. And that is the same thing as 4 to the negative x equals 4 cubed. So 1 over 4 to the x is the same thing as 4 to the negative x. So negative x must be equal to 3. And that means x is equal to negative 3. Okay, so the answer for this is x equals to negative 3. Okay, let's go to the next problem. Problem number 3. Okay, so this looks a little bit more complicated, but don't worry, we'll be able to solve it. Okay, so it says here 3 to the 2x plus 1 minus 4 to the 4 times 3 to the x plus 1 equals 0, and solve for x. The first thing we're going to do is let's think about how to approach this problem before we do anything. We see a 3 to the x here. Do you remember in problem 1 we had y equals 3 to the x? Well, we're going to try the same thing here because we see there's a 3 to the x embedded in the first term. So we're going to try to bring that out, set y equal to 3 to the x, and then see if we get a quadratic equation or some other equation that we can solve for y And then once we've solved for y, we plug in the value for x, and then we solve. What I mean is we plug in the expression for x that y represents, and then we solve for x. So that's what we're going to try to do. So let's try to extract to the 3 to the x, but let's do it step by step. So the first step is to say 3 to the 2x times 3 to the 1 for the first term. We can do this because they're the same base, the exponents add, so it'll be 2x plus 1, like up here, but we just separated them out like this. Okay, minus 4 times 3 to the x plus 1 equals 0. Okay, we can take this 2 up above like this, so 3 to the x to the 2, all right, times 3. I'm getting rid of the 1 there. It's still there, but I'm not writing it. It's a 3. But see what we did here. This is x to the 2. 3 to the x to the 2. So it's 3 to the 2x. It's not 3 to the x squared. It's 3 to the 2x because the 2 gets multiplied with the x. Okay? All right. Minus 4 times 3 to the x plus 1 equals 0. Okay. So let's let y equal 3 to the x. Okay, now we're going to simplify stuff here. This is y squared times 3. So let me write it like this actually. Y squared times 3 minus 4 times y plus 1 equals 0. So wherever I saw 3 to the x, I put in a y. That's what I'm doing here. Okay? So let's move to the next step. Okay, let's first write this without all the parentheses. So it's 3y squared minus 4y plus 1 equals 0. So this is not an easy one to factor. So what we're going to do is, at least at face value, it's not an easy one to factor. So what we're going to do is use the quadratic formula. And we can see that this equation fits the form that I'm writing now, which is the standard form for quadratic equations. And since y is our variable, I put y here. Okay? And in our equation, a is equal to 3, b is equal to -4, and c is equal to 1. Okay? And the quadratic formula says y is equal to -b plus or minus, and there's a square root, b squared minus 4ac divided by 2a. Okay, so let's plug in values for a, b, and c. So b was -4, so negative b is 4. And that's plus or minus. b is -4, so -4 squared is like this. It's going to be 16, but I'll write it like this for now. Minus 4 times a, which is 3, times c, which is 1. Okay? That divided by 2 times a, which is 2 times 3. Okay. Let's simplify this. Y is equal to 4 plus or minus. 4 squared is 16. 16 and 4 times 3 is 12. 16 minus 12 is 4. Okay? Divided by 2 times 3, which is 6. Y is equal to 4 plus or minus 2 over 6. So now there's two paths that we can take. One of them is y equals 4 plus 2 over 6, which equals 6 over 6, which equals 1. And the other path is y equals 4 minus 2 over 6, which equals 2 over 6, which equals 1/3. Okay, now let's go look at what y is. Y is 3 to the x. Okay, so let's put in that 3 to the x equals 1. So x must be equal to 0. That's one of the solutions. The other one is 3 to the x is equal to 1/3, which equals 3 to the -1. So x is equal to -1. Okay, that's the other solution. So it's either this one or this one. And both are solutions to this problem. Okay, keep an eye out for Logarithms and Exponents Practice Part 2, where we'll talk about some rate-related questions and appreciating and depreciating values. Um, Please make sure to subscribe to our channel if you're interested in hearing about when we have more videos, and please turn on your notifications. Thanks, and hope to see you in the next video.